Seventh grade, welcome to chapter 3. This is, in my opinion, the most important chapter that we do the entire school year. So this is the time to take the best notes and to use those notes to study and to really get a good grasp on what's going on. There are absolutely no calculators in this entire chapter. If you use calculators, you are not going to learn these important skills and you will struggle for the rest of the school year. So I know that's a serious way to start a video, but I need you to know how important this chapter is and how much I expect from you. Okay, so let's get started. This is chapter 3, all about these things called integers. You will get that definition in a minute. This lesson is about integers and absolute value, and we are going to jump right in with some vocab. So, very first vocab word is integer. Notice there's only one R in the word integer. Seventh graders love to add a bonus R and call it an integer. Nope, just integer. And an integer is any positive or negative whole number, including 0. In your note packet, I did not leave a space for you to write examples, but you have space that you can put them on the line or underneath. Some examples of integers are 5, 10, -8, -7, and 0. Don't forget 0. 0 is really important here. Okay, some non-examples. I want you to write them down too. Non-examples, 1 76/100, pi, and 3/4. They're non-examples because they're not whole numbers. Okay, so these are only whole numbers, positives and negatives, and don't forget 0. That's what an integer is. Okay, absolute value, that's a really important skill we're going to talk about today. Absolute value is the distance between a number and 0 on the number line. Distance is a positive measurement. You would only use positive numbers to describe distance, so that has a lot to do with what happens with absolute value here. And something for you to know is the symbol for absolute value is a double set of bars that look like that. So they'll be around the number or the expression, and they'll be large vertical bars. Okay, so let's jump into an example here. Absolute value, these are our notes. Absolute value makes any number positive. Remember, we just talked about absolute value being the distance between any number and 0 on the number line. So absolute value is a distance, which means it makes the value positive. Absolute value is solved during the parentheses step of the order of operations. That's really important for us to know too. So we kind of treat them like they're a grouping symbol, like parentheses. Okay, let's look at an example. The absolute value of 4, you got a number line on your note packet, so I want you to take a look at that. The absolute value of 4 means we go to 4 on the number line and we count how many spaces it takes us to get to 0. So that's 1 space, 2 spaces, 3 spaces, 4 spaces. Okay, 1, 2, 3, 4. So the distance between 0 and 4 is the number 4. When you simplify an absolute value expression, the absolute value bars must go away. If you still have these bars in your final answer, it's not fully simplified. So let's do the other one here, -4, the absolute value of -4. So we go to -4 on the number line, and we find out how far that is from the number 0. 1, 2, 3, 4 units. So the absolute value of -4 is also 4. So both of these expressions are equal. They have the same answer because it's how far is that distance? What's the distance between that number and 0? Okay, let's take a look at a couple examples. Lots of example problems in chapter 3. You're going to see lots of example problems because I know we need to see them. So stick with it. Okay, number 1, so we're doing the absolute value of -5. Remember, we turn that number to be a positive 5 because -5 is 5 units away from 0 on the number line. And we're done. As soon as those bars are gone and the number is positive, we're finished. Number 2, the absolute value of +6. Well, we can make it positive. It already is positive, and get rid of those bars. Number 3, here's a review for us. Parentheses, exponents, multiply and divide, add and subtract. So we do the absolute value bars in the parentheses step. So in this case, the first thing we have to do is get rid of our absolute value bars. So there's no problem inside here. We just have to make that number positive. The absolute value of 7 is 7. The absolute value of negative 5 is positive 5. Bring that subtraction sign down. And now we can finish the problem by doing the subtraction. 7 minus 5 is 2. Okay, make sure your work looks like my work. In this case, we do these like they're parentheses. Just make them the positive numbers and you can subtract. Number 4 is a little different because this time we've got a problem inside the absolute value bars. So if these were parentheses, we'd have to solve the problem first. So that's what we're going to do here. First we solve the problem, but our bars stay there. 12 minus 6 is 6. Now we can do the absolute value in the next step. The absolute value of 6 is positive 6. Okay, these two problems, very different. In this case, we had to make the numbers positive first. In this case, we had to subtract first and then make it positive. And it's because of how the bars were situated in the problem. Okay, number 5, the absolute value of 2 times 6 minus the absolute value of negative 4. So first we have to do our absolute value bars, part of the parentheses step. So in this set, there's a problem inside first. So that means that we bring our bars down and we take 2 times 6 and we get 12. Okay, so now each of our sets of bars only have one number inside. Now we can make what's inside positive. The absolute value of 12 is 12. The absolute value of negative 4 is positive 4. And now we can subtract. 12 minus 4 is 8. Got one more problem hiding down here. This is one big set of absolute value bars with a bunch of problems inside. So every step of the way, we bring those absolute value bars down until we have only one number inside, and then we can make what's left positive. So order of operations, we've got division coming before addition. So 18 divided by 3 is 6. 6 plus 7 is 13. Notice I'm carrying those bars down the whole way. Now that I have one number inside the bars, I can make that number positive and get rid of my bars. Okay, last one. This one's really, really easy, but a lot of 7th graders struggle with these because they think they're asking something else. I just want to make sure you know what I'm asking in this problem. It says a credit card is used to purchase items on credit so the purchaser can pay for the items at a later date. What integer can be used to represent a credit card purchase of $75? This is not an absolute value problem. This is basically asking, we know we're going to deal with the number 75 here, but is that 75 going to be a positive or a negative number? So since we are borrowing that money from the credit card company, we're technically in debt, which means the 75 will be a negative number. So that's all you have to do for this problem. No need to add any absolute value bars. This isn't that type of problem. It's basically just asking us, should we make it a negative number or a positive number? And the answer is negative. Okay, go ahead and do your practice problems. Ask any questions that you have tomorrow during class.